Hi, my name is Loeskow, and I'm a current mechanical engineering student at Central Queensland University. And today I've come to talk to you about evaporative cooling. So what is evaporative cooling? First of all, I want to ask you the question. Have you ever experienced a nice refreshing ocean or river breeze? Unless you live in the middle of Australia with no rivers close to you, most of you have. You feel much cooler because as the hot air blows across and directly above the water, it causes some of the water to evaporate and absorbs the heat. This is why you feel cool and refreshed, because as the water is absorbed into the air, it absorbs the heat also, and which cools the air and adds more moisture to the air too. One of the most common functions of an evaporative cooling system is the evaporative cooling air conditioner, which is a non-compressor based air conditioner system. Here's an example of the system. As you can see, it works much like the activity when the hot air blows across the water. As the hot air blows into the system, it uses wet pads here, which get given water from a water tank, which is pumped up using a type of pump, and then as the hot air blows through the wet pads, it uses the same principles as the sea breeze, which cools the air. It also uses a fan or a variety of different fans to help speed up the process and make the system much more efficient. Here is the most common function of the system, how it is installed into a general house. Some of them can be added on top of the roof, which is helps the aesthetics of the system, or some of them can be in an isolated area, which is away from places that need to be quiet, as the system may make some noise. It uses ducting to blow the air as the cool air goes out of the system, and then it goes through ceiling outlets, which then travel throughout the house. Some of the systems may just be only have one duct, and it's just pumped like straight cool air into the one position. And some of the houses might also have vents, which allow the moistured air to travel out, so it's a constant cycle of the cool air. But I'll go in more detail on that soon. The advantages of having an evaporative cooling system is that it delivers fresh cool air, because as the air travels through the wet pads, it basically, it's just general air that's from outside, and the wet pads also help recycle and filter the air. One of the biggest advantages of the system is that it uses up to 80% less electricity than comparable refrigeration systems, which are the most common air conditioning systems. This is great because it reduces the cost of air conditioning by a massive amount, and it greatly reduces the environmental impact of the system, which is also a very important factor to consider. Another advantage is that it adds moisture inside the building, so this can help with dry eyes, and it can also help just refreshen up the place and help indoor plants. Here is a table, a figure illustrating how great the central evaporative cooling system is compared to refrigeration air conditioning systems and split system air conditioning systems, which are very common. The refrigeration air conditioning system uses 87 costs 87 cents per hour in 150 meters squared, which is a huge amount when considering that's almost $1 per hour. While the split system air conditioners use 27, which is a massive drop, and then even more of a drop is that is the central evaporative cooling, which is the main topic. It only uses 12 cents per hour for 150 square meters, which is definitely much better than the ducted refrigeration air conditioning and most common air conditioners when considering the total cost and the environmental impact. Although those advantages seem great, which they are in terms of sustainability, the economical sustainability and the environmental sustainability, it also has some disadvantages which go towards social sustainability. For example, the system only works well when when the system has a constant supply of fresh air from outside, or the house will get saturated and will not cool the area. And also, it only works in dry climates, so that's something that needs to be considered. So it's classed as a swamp cooler, which is another word for it, and it because it adds moisture to the air. If the air already has moisture in it, then the system won't work very well. The house would just get saturated because they have, number one, too much water, and the extra water won't actually do that much because the moisture in the air will already be pretty hot, so it won't have the same effect. Also, to help spread out the air through the house or building, the windows must be left open, and this can actually cause more dust and pollen to enter the house, which is a risk if you have allergies, and it can cause problems. And it is also a security risk because most people don't like leaving their windows open. And another option is to install vents, but that also adds it also adds a more installation cost. It requires a large amount of water. For most people it's not very large, but if you're in an area which doesn't have much water, then it can play a big factor. And one of the biggest problems is that the wet pads can form mold, and this is the part that needs the most maintenance, because it's wet for so long. This can cause mold, and with the mold, as the air passes through, some of the air will have the mold in it, which can cause pretty bad illnesses for the people inside. So it's very important to keep them maintained, and also because they need to be maintained pretty often. If it's installed on the roof, this can actually be pretty difficult. Here's a simple experiment to prove theories of the evaporative cooling system. All you need is a washer or a piece of material that can soak up water. You need some water, a hairdryer or a compressor that blows the air, and a thermometer. What you need to do, you need to soak the washer and then basically just blow the air through it and feel the difference, or you can actually use the thermometer to test the difference between the hot air as it goes out of the hairdryer and the air that goes through the material. I hope this lecture has helped improve your knowledge about evaporative cooling, and thanks for listening.